Hello, let's start the 7th lecture. Today, we're going to learn more about the list type. An index of a list must always be an integer greater than or equal to 0. If you use a float type number as an index, the Python interpreter throws an error. All elements of a list have non-negative indices, but like in strings, it is possible to access the last element of the list with -1. Parts of lists can be accessed by slicing like a string. The syntax is the same as string slicing. Run the following code and see the result. From index 2, you can see that A and B are added to list A. Assuming there is a list A, assigning a list to A n colon n means putting elements of the list into the index n of list A. Inserting new elements in the middle of a list using a syntax similar to slicing is called squeezing. Last time, we learned that an element of a list can be deleted using the del keyword. Similarly, multiple elements of a list can be deleted using the del keyword. If you run the program shown in the slide, you can see that the elements from index 1 to index before index 3, which is index 2, have been deleted. You can use the plus operator to concatenate two lists. As shown on the screen, when there are two lists A and B, if you want to create a new list by appending the elements of B to the list element A, you can concatenate the two lists through the expression A plus B. Also, some lists can be lengthened by using the asterisk operator. For example, if you multiply a list by 2, you get a new list in which the elements of the list are repeated twice. As shown in the slide, if we multiply the list A by 2, we get a new list that is twice the length of list A. Similarly, multiplying by 3 gives the new list in which the elements of the original list appear 3 times. The list type provides various methods. For example, if you want to sort the elements in a list, you can call the method list.sort. After calling the method, the elements of the list are sorted in ascending order. Note that when the list.sort method is called, the order of the elements inside is changed. If you do not want to change the original list and want to get a new list with sorted elements, you can use the sorted function. If you pass a list as an argument to a sorted function, the sorted function returns a new list in which the elements in the argument list are sorted in ascending order. Therefore, the original list that was passed as an argument will not be changed. The count method is a function that returns the number of elements in a list that have the same value as the value given as an argument. For example, the code mylist.count7 returns the number of elements that are of value 7 in the list mylist. List.reverse method is a function that reverses the order of elements in a list. For example, if the elements of list A are 1, 2, 3 in order, when the code a.reverse is executed, A is changed to 3, 2, 1. If you do not want to change the original list, but want to get a new list in which the elements of the original list are reversed, you can get a new list by putting the original list in the reversed function and calling it. Of course, like the sorted function, the original list will not be changed after the reversed function is called. List also has a method called remove. This method examines the elements in order from index 0 to the last element. And if there exists an element that has the same value as the argument value, the first of them is removed from the list. For example, assuming there is a list A, which is 151, If A remove 1 is executed, the remove method removes the first one of list A, and list A becomes 5, 1. Also, there's a method called index. If any value is given as an argument to the index method, this function returns the index of the first occurrence of the value given as an argument. Let's say there is a list called myList. When myList.index1 is called, the index 0, where the value 1 first appears, is returned. You can put a list inside a list. Let's run the code on the slide. First, put 1, 2, 3 in the list, and assign this list to a variable called A. And let's print A0. Since we put a list with 3 elements in the list A, the element at index 0 is a list 1, 2, 3. The type of A is list. Since A0 is 1, 2, 3, we can think of A0 as a list. Thus, A00 is equivalent to accessing the value at index 0 of the list A0. So if you print A00, it'll print 1. Of course, printing A01 will print 2, and printing A02 will print 3. A list that has a list as an element is also called a two-dimensional list. Let's look at another example. A list with 2 lists as element is assigned to a variable A. Now, let's think about what happens if we run the code on the slide. First, there is a list 1, 2 in A0, and in A1 there is a list 3, 4. So the value of A00 is 1. The value of A01 is 2. The value of A10 is 3. The value of A11 is 4. If you put a two-dimensional list inside a list, you can call it a three-dimensional list. For example, the list A on the slide has two-dimensional list as an element. Naturally, if you print the index 0 of A, a two-dimensional list is printed. And even if the index 0 of the first element is printed, a list will be printed. Of course, the type of A is list. The type of A0 is also a list, and the type of A00 is also a list. And elements in A00 can be accessed using square brackets as shown on the screen. Since we can put lists inside a list, it is also possible to create n-dimensional lists. And the way to access the elements in it is the same as accessing the elements in a two-dimensional or three-dimensional list. By using the enumerate function, we can get both the value and index of the element in the sequence when we run the for loop. Enumerate function converts any sequence into a sequence consisting of tuples of index, element, and returns it. Let's see the code shown in the slide. If you run the for loop by putting animals in the enumerate function, you will see the same results in the console as shown in the slide. We print the variables I and animal at every iteration. As mentioned earlier, the enumerate function converts the elements of a certain sequence into tuples and returns them. Each tuple consists of the index of the corresponding element and the value of the element. The index of the element is passed to I, and the value of the element is passed to the animal variable at every iteration. Implement a function SUMList that takes two lists of two integers and returns a list of the sum of each element of the two lists. For example, if A is 5, 3 and B is 2, 6, then the function should return 7, 9. If the two lists are of different lengths, return an empty list. For example, we can implement the function like this. First, compare the lengths of the two lists. If the lengths are different, return an empty list. Otherwise, the code continues to run. Create SUMList variable to use it as a return value. Then, using the for loop, increase I from 0 until it reaches the length of the list A, and append the calculation result of AI plus BI in the SUMList. And we can return SUMList after the iteration. Earlier, we learned that we can sort a list in ascending order using the sort method. What if you want to sort a list in descending order? The list.sort method has a parameter called reverse. If no value is passed to this parameter, the list is sorted in ascending order. However, if you assign true to the reverse parameter, the list is sorted in descending order. The sorted function also has a parameter called reverse. If you want to make a list C in which the elements of list B are sorted in descending order, as shown on the slide, you can set the reverse parameter to true when calling the sorted function. A parameter with default value like reverse is called optional parameter. There are a few things to note when calling a function with these optional parameters. Pause this lecture video and predict what values will be printed when the following program is executed, and then continue playing the lecture video. When you run the program shown earlier, the following values are displayed. Calling the hello function on line 4 returns 5 times 6 plus 7. In line 5, only C gets 4, so 1 times 2 plus 4 is returned. In the next line, only the first two parameters receive arguments, so 8 times 9 plus 3 is returned. If you run the code in line 7, only A is assigned an argument, and 10 times 2 plus 3 is returned. In the next line, only the values of B and C are set, so 1 times 3 plus 4 is returned. If you want to initialize only certain parameters in a function that has optional parameters, it is better to specify the parameter. If the parameter is not specified, the passed arguments are assigned in the order in which the parameters are listed. Python provides a number of functions related to lists. For example, if you want to calculate the sum of all elements of a list, you can use a function called sum. If you pass a list as an argument to the sum function, the sum function returns the sum of the list elements. The min function is a function that returns the value of the smallest element among the elements in a list. And the max function receives the list as an argument and returns the value of the largest element of the list. We learned that strings are immutable and lists are immutable. Among the data types discussed so far, lists, dictionaries, and sets are immutable types, and types such as int, string, float, tuple, and bool are immutable types. We learned that when an assignment happens, we create a space and put a value into the space. However, values of immutable data types are actually stored only in one place. Therefore, when storing values of the same immutable data type in multiple variables, those variables point to the same memory address. The ID function is a function that checks which data is stored at which address in that memory and returns the address. The returned address value is a number. Predict what values will be printed when you run the code on the screen. If we run the program shown in the previous slide, we can see that the following values are printed. First, variables a and b are assigned the value 1 of type int, which is an immutable data type. Therefore, both variables will have the same data address. However, if b is assigned 2 instead of 1, the two values are immutable but different, so they will have different data addresses. Sometimes when creating a function, it is necessary to receive a list as an argument and process it. When a list is passed as an argument, and if the list is modified inside the function, the original list outside the function is also changed. If we run the code shown on the screen, we can see that the list variable lst outside the function is changed after the function call. When passing an int or float as an argument, this will not happen. But for a mutable data type such as list, the original data address is passed to the parameter variable. In Python, immutable data types refer to the same address. For example, if you store the string deep block in both string 1 and string 2, the Python interpreter stores the same address in string 1 and string 2 variables, and deep block is stored in that space. Of course, all variables need a space to store the address of its value. However, if a string is very long, or in the case of an immutable variable with multiple numbers or data, such as tuple, it is much more advantageous to store only one address number in the variables. For example, when we assign a large tuple with the same value to two variables, we can store a large tuple in one space without having to create two new large spaces, and we only need to store the address where the value is stored. This allows you to save memory space by storing only one tuple instead of two. A list, on the other hand, is a mutable data type. When the Python interpreter assigns a list of the same elements to two or more different variables, the Python interpreter creates a separate space for each and stores them. This is because, in the case of an immutable data type, the value inside any variable cannot be changed. But in case of a mutable data type, the value inside any variable must be able to be changed. If we create two list variables with the same elements, and if we change the elements of one list variable, eventually we won't be able to use the same space. Therefore, in the case of a mutable data type, it is meaningless to store values in the same space. Rather, it is more efficient to store the value of a mutable type variable in an independent space so that we can easily change them without affecting the other variables. Therefore, as shown in the slide, even if you assign the list of same elements to two list variables, list 1 and list 2, the two variables store values in different spaces. If you want several list variables to share the same space, you can assign one list to another list. However, usually this is not a common practice. What if you want to copy only the values of a certain list and store them in a new space? In this case, you can use slicing to create a new list by copying the elements of a list. As shown in the slide, when there is a list variable list1, if list1 colon is assigned to another variable list2, list2 copies the entire value of list1 and stores the list in a new space. Another way is to use a method called copy. The list.copy method creates and returns a new list with the same elements as the list. For example, the code b equals a.copy assigns a copy of list A to the variable b. Therefore, ID values of two variables are different. Let's solve an exercise problem. Implement a function .product that takes two lists and returns the dot product. The dot product is defined as the sum of the products of each element of the two lists. For example, if the lists 1, 3, and 2, 4 are passed as arguments, the dot product becomes 1 times 2 plus 3 times 4, and 14 is returned. If the lists are different lengths, return an empty list. Here is an example answer. When the two lists are of different lengths, we return an empty list. If the two lists have the same length, create a variable called dotted and initialize this value to 0. The for loop is executed until the value of I goes from 0 to the last index of list 1. At each iteration, we add the product of each list element to a variable called dotted. And when the loop ends, just return dotted. If you call this function with two lists 3, 5, and 2, 3 as arguments, this function returns 21, which is the dot product. This is the end of today's lecture. Next time, we will learn about file input and output.